Do you guys see where it says conjugates? Okay, I need you to write a few things up on your paper, okay? The first thing that I want you to write, and these are some properties of square roots, actually radicals in general, okay? I'm trying to fix it. The square root of 14, excellent, okay? This one we can do, this one we cannot do, okay? Let me show you one more example. Okay, the next one. Let's say we had the square root of 3 plus 2 times the square root of 3. Kind of, okay? We're going to treat the square root of 3 like it's an x, or a variable. If we had x plus 2x, what would we get? If we had x plus 2x, what would we get? 3x. And if we had square root of 3 plus 2 times the square root of 3, we would get 3 times the square root of 3.
Wait, why?
There's a one outside. There's an invisible one outside.
Jordan?
Oh, wait. Is there an invisible one in the...
That was actually a good question. Hold on. So Andrew asked, wouldn't it be invisible too because the index is 2? Guys, the coefficient, so you can have a 3 and then the fourth root of 7, right? The index is completely independent of this number out in front, okay? The number out in front is called the coefficient, right? That's the number of radicals that you have. So we have 3 fourth roots of 7. Okay, so if you have 1 cubed root of 3, or 1 square root of 3, and 2 square roots of 3, you add them together, you get 3 square roots of 3. Do you guys see that? Kind of?
Yeah.
Okay, let's do one more. Let's say we had 3 square root of 5 minus 2 square root of 5. It would equal what? It would equal 1, the square root of 5, which you guys know you can rewrite as just the square root of 5. Yes?
Yes.
Okay, one more. Let's say we had 3 square root 2 minus 3 square root 3 plus the square root of 2.
Equals the square root of 3 and then the square root of 2.
Okay, let's see. So, which of these can I combine and why? Hannah?
You can combine this outside. You can combine 3, -3, and the 1.
We cannot combine all 3 of them. Diego?
We can combine the two, I don't know how to say it. The radical with the 2's.
Very good. We can combine the square root of 2. So 3 square root of 2 plus the square root of 2 is going to give me what?
4 the square root of
4 times the square root of 2. And then this one is just minus 3 times the square root of 3. Okay? So anytime your radical is the same, you can add their exponents. Okay? When they're different, you have to treat them as if it's like x and y. Can you combine x and y? No, because they're not like terms, right? Same thing applies to radicals, okay? Now, we are going to see a lot of problems with... So, there's something called a conjugate, okay? So when you have an expression, right? For example, let's write this down. The square root of 2 minus 2 times the square root of 3, right? Do you agree I cannot combine these guys? Are you guys in agreement with that?
Yes.
Okay. Now, the conjugate, all it says is change the sign of only the second term. Okay? So, my first term is this one, the square root of 2. You don't touch him. So you rewrite it the square root of 2. The second term, was it a positive or a negative term? It's a negative term. It's negative 2 times the square root of 3. So change him to positive. So it's going to be plus 2 times the square root of 3. This is what we call the conjugate. It's the conjugate, okay? Not necessarily the answer, okay? Now, the conjugate is very useful, and I'm going to explain why it's useful in a moment, okay? But that is what we call the conjugate. Let's try a few more. Let's say we had the square root of 4 minus, no, not 4, because we know that one. Let's say we had the square root of 5 minus 3. First off, can we combine these? No, okay, because one's in a radical, one is not. So, if I were to ask you, okay, find the conjugate of this, what would you do? Yep.
The square root of 5 plus 3.
Very good. It would be the square root of 5 plus 3. Do we touch the first term? No, it stays the same. What happened to the second term? It changes sign, okay? Let's do another one. Let's say we had 6 minus the square root of 3. Nope. We're going to put plus here and negative 6. Negative 6 plus the square root of 3. What would be the conjugate of this? Diego?
Negative 6 minus the square root of 3.
Very good. Did we change the sign of the first term? No. Did we change the sign of the second term? Yes. Okay. Now, conjugates are very, very useful, right? When we see examples like we're going to see on the next page, okay? So, jump to the next page and look at example A, okay? This expression is almost completely simplified, but there's one thing that's somewhere where it's not supposed to be. Gabby? Very good. You cannot have this radical in the denominator, okay? Now, before, right? You guys agreed we would deal with this problem by multiplying by the square root of 3, right? To both the numerator and the denominator. But because it's 2 minus the square root of 3, that will not help us at all, okay? So what we do, and write this down, is you're going to multiply by the conjugate. Okay? And then something really, really cool happens, and you lose your radical completely, okay? So, take a look at the denominator, which is 2 minus the square root of 3. What would be the conjugate of that denominator? Sophia?
2 plus the square root of
Very good. So, write down we're multiplying by 2 plus the square root of 3. And if we multiply to the denominator, where else do we need to multiply? The numerator by the exact same thing, okay? So now watch. We're going to get 7 times 2 plus the square root of 3 over 2 minus the square root of 3 times 2 plus the square root of 3. You guys agree we multiply fractions by multiplying them straight across, correct? Okay. Now, someone tell me, what do you think I do with the 7 to multiply it by 2 plus the square root of 3? We're talking about this numerator. Sienna? Excellent. You have to distribute the 7 to both the terms. So what's 7 times 2, guys? So that's going to be 14. Plus, what do I get when I multiply 7 and the square root of 3? It's not the square root of 21. Why isn't it the square root of 21, guys? Jordan? Very good. One has a radical, one does not. So, Jordan, what do you think we should get instead? Excellent. It's going to be 7 times the square root of 3. Do we see that? Okay. Now, this denominator, I want you to underline him, highlight him, whatever. We need a little bit of extra space, so I'm going to move him down here. It's going to be 2 minus the square root of 3 times 2 plus the square root of 3. We consider these two binomials. How do you multiply two binomials by each other?
You group them.
Diego?
I forgot what it's called, but like it's the first terms you multiply them, and then the first term and the last term
Ah, this is FOIL, okay? We are going to FOIL this out. So the first one is going to be 2 times 2. And what's 2 times 2, guys?
4.
It's 4. What's 2 times the square root of 3? 2 times the square root of 3. What's negative square root of 3 times 2? Negative 2 times the square root of 3. And negative square root of 3 times positive square root of 3. Negative square root of 9.
But isn't that just can't that out with 3?
Yeah, we will eventually, okay? So there's some stuff we can simplify here. Sophia, notice the square root of 9 is just 3, right? So change this to a negative 3. Leave this as a 4. What else?
It would be the negative 2 times the cube. It would be negative 4 times the square root of 9. Oh no, my bad. You add that. Wait. Oh no, they cancel out.
Yeah, they cancel.
So it would just be.
Oh, what cancels, Gabby? What cancels?
The 2 and the 2.
Very good. Do you guys see how we have the exact same term? One's positive, one's negative?
Yeah.
What does that give me? 0. Okay. So what's 4 plus 0 plus negative 3?
1.
It's just positive 1.
But don't you?
So check this out. Our entire denominator changed to 1. So we're going to take that 1, put them up here. So this whole thing is over 1. So what's my final answer?
14.
14 plus 7 times the square root of 3. Let's do another one together, and then I'm going to set you guys loose, okay? We've got 8 over 1 plus the square root of 3. Is this guy simplified? Why not?
Because there's a radical in the denominator.
There's a radical in the denominator. How can we get rid of that radical in the denominator? German? Very good. Multiply by the conjugate. German, what would the conjugate be here? Excellent. And we just multiply the bottom, right? No, we have to multiply the top as well, okay? All right. I'm going to rewrite this. It's going to be 8 times 1 minus the square root of 3 over 1 plus the square root of 3 times 1 minus the square root of 3. All right, someone take over and tell me what my numerator is going to be. What my numerator is going to be. Sophia?
8 minus 8 the square root of 3.
Very good. Okay. Did we distribute in the numerator?
Yeah.
Yes. Okay. What do I have to use for the denominator? Go ahead, Sophia.
If you already see that it's the same, but with opposite signs in the denominator, do you have to FOIL it?
No. Okay. If you know that this is difference of squares, okay, you can use that. Okay. Let's FOIL it. 1 plus the square root of 3 times 1 minus the square root of 3. Someone walk me through foiling this guy. Go ahead, Andrew.
You go to the first one, 1 times 1, it's gonna be 1. And then the outer ones.
Okay.
1 times negative the square root of negative 3. And then that just leaves you with negative 1 times the square root of 3.
Okay.
And then you do the inners, so negative 3 and 1, and it's the same thing except positive, so plus 1 times the square root of 3. And
Okay.
then the outers is negative 3 and positive 3 and negative 3, and that's just negative 9.
Negative square root of 9.
Yeah.
Mm-hmm.
And then from there, the last one, the negative square root of 9 is just 3, negative 3.
Mm-hmm.
And then on the inside, those two cancel out, so you just get a 1 minus 3, and that's negative 2. And then you put that over the original thing.
Very
right
good.
there, and you simplify it. Actually, no, you're not,
Okay. So this would get you the majority of the points, right? But just like Andrew said, it's still not completely simplified. Andrew, please don't answer this. How else could I simplify this? Javonsky? How do I divide by negative 2? What?
Okay, you multiply both the 8's in the numerator. You divide both the 8's in the
Good.
Not -2, and you divide the -2 denominator by -2.
Okay.
That can, and in the numerator, you get -4 plus 4 the square root of 3, that's square root of 3, and then the denominator, you get 1.
You get 1, right? Do we need to put that denominator of 1?
No.
No. So this is our final answer.
Can you put it with the?
Can you put the denominator as 1? I would prefer if you don't. Okay?
Wait, how did you?
All right. I will take all questions at this time, guys. Look over this example. Ask away. Hannah, what's up? Andrew, go ahead.
Okay, so the conjugate, right?
Yes.
The conjugate is always just what's on the denominator, like whatever we cancel out the denominator.
Correct. We want to use the conjugate of the denominator because we need to get rid of the square root. And the conjugate does that. Okay?
Does the conjugate just like you figure out the conjugate by like what's the conjugate? Like how do you find it?
You just make the second term negative.
Alright, thank you.
Yep.
How do you get the 8 minus 8?
The 8 minus 8. So I took this 8, which was outside my parentheses, right? And I just distributed them inside. So what's 8 times 1? 8, right? And then 8 times negative root 3 is 8 times root 3. Do you see it now?
Yeah.
Okay. Good questions, guys. Any other questions? Okay, try C on your own. We'll go over it. Don't work on it as a group. Don't work on it as a group. What did we multiply by to get rid of the square roots? What did we multiply by to get rid of the square roots? Diego? What do we multiply by to get rid of the square roots?
The conjugate of the denominator.
Very good. The conjugate of the denominator. What is the conjugate of the denominator? Adrian?
Square root of 2 minus square root of 7.
The square root of 2 minus the square root of 7. Yes? Square root of 2 minus the square root of 7. When we multiply that in the numerator, what do we get? When we multiply this in the numerator, what do we get? Sebastian?
12 times square root of 2 minus square root of 7.
Try it again. You're missing one thing. What is he missing? Andre? Because the conjugate, you always change the second term to negative, okay? Sebastian, what are you missing here?
The 12.
The 12, okay? You have to distribute this 12, guys. Are we going to remember to distribute? Okay. Yeah, Diego?
When I show my work, I usually distribute more towards the end. Is that okay?
That's fine, okay? As long as you distribute, I'm happy. The bottom. What do we have to do with the bottom here? You foil it, okay? Jasmine, can you walk through foiling it? Two.
And then the square root of 2 times the square root of 7
Yes, it is, but it's going to be negative the square root of 14.
and then you times the square root of 7 times the square root of 2, which is going to be plus the square root of 14.
Mm-hmm.
And then you times the square root of 7 times the square root of 7, which is going to give you negative 49.
The square root of 49. Very good. Okay. The 14s are going to cancel out, okay? Because one's positive, one's negative. So we have 2 minus the square root of 49. What do we know about this problem?
2 minus 7.
It's minus 7. 2 minus 7, which gives me negative 5. So your denominator here is negative 5. Does this simplify further? But why does it not simplify further? Diego?
There's no greatest common factor.
Correct. There's no greatest common factor between 12 and 5. Yeah, Hannah.
I see what I do wrong. I want to say this and you would like some other thing.
I would appreciate that.